Module 1, Session 3, and this lesson is called Benchmark Angles. All right. So before we start the lesson, I want to go over the answers to your homework from last night, which was a review of area and perimeter. So a review of area and perimeter. So we know that the first one was done for you. All right, by looking at the second one, the perimeter around would be 4 plus 4 plus 4 plus 4, which would be 16 units, right? And then the area would be 4 times 4, which would also be 16, but that would be 16 square units. For B, the perimeter around, you would have 4 plus 6 plus 4 plus 6, and that would be 20 units. And the area inside would be 4 times 6, which would be all of this space, or if you just counted how many squares there were, that would be the area, which would be 24 square units. And for C, for the perimeter, it would be 3 plus 7 plus 3 plus 7, and that's 20 units. And then the area, or how much space it takes up, would be all of these, which would be 3 times 7, which is 21 square units. Okay, now there was a challenge problem. It says find the area and perimeter of this shape, show all of your work. Okay, well, if you look here, we have, this is 8, and this is 8, right? And if this is 2, that means that this is 6, and if this is 3, that means that this is 5. Okay, so the perimeter around would be 5 plus 2 plus 3 plus 6 plus 8 plus 8. So you have 5 plus 2 plus 3 plus 6 plus 8 plus 8, and that would be 32 units. Now to find the area, okay, you could take 8 times 8, which is 64, minus this 3 times 2, which is this little piece of area right here that isn't really part of the shape. So if you did 8 times 8 minus 3 times 2, that would be 64 minus 6, which would be 58 square units. Okay, or you could think 5 times 2, which is right here. So here's 5 times 2, okay, plus 8 times 6. So if you added the areas of those two, that would be 10 plus 48, which would also give you 58 square units. Or you could do, different color here, you could do 6 times 3, which is the area of this spot right here, plus 8 times 5, which is 18 plus 40, which also gives you 58 square units. So 3 different ways to solve the area for that one. The perimeter would be 32 units, and the area would be 58 square units. So there are the answers to page 89. All right, on page 90, it says, you can make sketches to help solve the problems below. Remember to include the units of measurement in your answers. Show all your work. So the classroom rug is 9 feet long and 8 feet wide. What is the total area? Well, I know that 9 times 8 is 72, so 72 square feet. All right. For B, what is the perimeter? Well, that would be 9 plus 8 plus 9 plus 8, okay, which would give you 34. Chrissy is going to make a big painting on a piece of wood that is 4 feet wide and 7 feet long. What is the total area of the piece of wood? 7 times 4 equals 28 square units. Now, if you remember, area takes up space, so we say square units because we're talking about the amount of space it takes up, okay? And then for what is the perimeter of the piece of wood? That would be 4 plus 7 plus 4 plus 7, which would be 22 feet. When you're talking about perimeter, you don't have to square it because it's simply the distance around, okay? And then the school playground measures 465 feet by 285 feet. What is the perimeter of the playground? That would be 465 plus 285 plus 465 plus 285, which would give you 1,500 feet. All right. Okay. Moving on now. Here we go. So for Unit 5, Module 1, Session 3, which is benchmark angles, today we will review what right angles and straight angles are. Okay. We're going to review those two things. We will then learn about a new term called interior angle, and we will use right and straight angles as benchmarks to determine the measure of the interior angles in pattern blocks. Now I know that we don't have pattern blocks in front of us, but I'm going to help you out with this. And then finally, we will use pattern blocks, or the ones that Mrs. Sanders will help you with, okay, to measure angles of rotation on a clock face and to determine the fraction of a complete turn represented by each angle of rotation. Okay. So before we get any farther, I just wanted to kind of talk about what interior angles are. So when you're looking at polygons, which are closed figures or closed shapes, so, you know, you have your square, you have your rectangle, okay? Now, when you look at a square and you look at a rectangle and you look at a triangle, these are all polygons, okay? Those are closed figures, right? Okay, so interior angles, if you just think of interior, that would mean the inside. So the interior angles are the inner angles, okay? So you can see that on this shape right here, the interior angles are red. Those are the angles on the inside. And then the other angles are considered exterior, so outside angles basically. And then when you look at this figure right here, you have your interior angles are all highlighted in a different color, okay? So interior means inside. Interior equals inside or inner angles. Okay. All right. So remember that right angles are exactly 90 degrees. Okay. So keep that in mind. Right angles are exactly 90 degrees. Straight angles are exactly 180. So if I were to draw a right angle that was exactly 90 degrees. Now I know this isn't going to be perfect because I'm drawing it, okay? And then I drew another right angle right here, which is also exactly 90 degrees. You can see that a straight angle is basically two right angles that are, you know, back to back or right next to each other, and they measure together 180 degrees, okay? Because 90 plus 90 equals 180, right? So mathematicians measure angles in degrees. So I know this is kind of blurry, but in the picture, you can see that the angles of the triangles, so if we had our pattern blocks, which we don't have them, that's okay, but here's a picture of pattern blocks. If you were to take 3 of the triangle pattern blocks and put them together, now we know that in a triangle, for equilateral triangle, which means that all the sides are the same length and all the angles are the same, for all 3-sided figures, so all triangles, their angles add up to 180, okay? So if you have an equilateral triangle, that means that the measurement of this interior angle would be 60, the measurement of this interior angle would be 60, and the measurement of this interior angle would be 60. So they would all be 60, okay? Now if I were to put 3 of my pattern block triangles together, you could see that this angle and this angle and this angle right here, they're all 60, which would mean that together they make a straight angle, which would be 180 degrees, okay? So that means that each angle is 1/3 of a straight angle. So a straight angle is 180 degrees. So each of the triangles must be 60 degrees, right? Okay, so just keep that in mind as we keep going on, okay? All right, so also I'm gonna remind you again that remember that right angles are exactly 90 degrees, okay? And straight angles are exactly 180 degrees. Okay, so mathematicians, again, they measure angles in degrees. So I want you to look at these pictures right here. And if you look very, very carefully, I'm going to split this hexagon up and you will start to see something, okay? Now, if you look very carefully, you will notice that if we had a yellow pattern block hexagon, we could actually put 6 of our triangles together, and that would mean that they could make the hexagon together, right? And so when we were talking about the measurement of angles, we know that this is 60, this is 60, and this is 60, which means that this is also 60, this is also 60, and that is also 60, okay? Also, if we had the blue rhombus, let's say, okay, you can actually take and put 2 triangles together to make the blue rhombus shape pattern block that we have at school, okay? Now, if we were to do that, we would also know that this angle would be 60, this would be 60, this would be 60, this would be 60, that would be 60, and that would be 60 because it takes two triangles, okay? For number 3, that would be our green triangle, right? So we already have a green triangle pattern block at school, and we've been even just talking about it right now with our hexagon and our rhombus, which you can make both of those shapes with the green triangles, okay? So now, if you were to just think about the actual green triangle, we know that the measurements of the angles are 60, 60, and 60. Okay, so here's that trapezoid that we were talking about earlier. Now in our pattern blocks, if we had them right now and we were at school, the trapezoid is red, and I can make the trapezoid. Now, if you also look very carefully, the trapezoid is half of that hexagon. So I would basically go like this, and I would have my 3 triangles, right? Okay, and then you have your square. Well, the square is orange at school. And when you look at a square, right, it has right angles. So I know that each of these angles is 90 degrees. Okay. Then you have this other shape right here. Now this is kind of like a stretched out rhombus, okay? And this one is a little trickier. It's much harder to see, okay? And I just want you to think about what it could be. So I know that when I'm looking at this angle right here, I see that it's bigger than this angle right here, okay? Now, going back to number 4 for a second, if this is 60 and this is 60, then together these must be 120, okay? Now, when I look at this angle versus this angle, this one right here is much smaller, and it looks to be about half the size. So if it were about half the size, okay, then I'm just going to take a wild guess that maybe this one's 30. So if this one's 30, that would mean that this one is 30, okay? If these are 30, now in a triangle, I know that all of the angles of a triangle measure up to 180, okay? But that's not the case for when you have quadrilaterals, all right? So I want you to just keep this in your mind for a second. Now look, the sum of the interior angles of a quadrilateral equal 360, okay? The sum of the interior angles of a triangle are 180, but the sum of the interior angles of a quadrilateral, now that should hold true, because if you think about 90 plus 90 plus 90 plus 90, well, 9 times 4 is 36, so that means that 90 times 4 must be 360, okay? So, knowing that, if we look at this stretched out rhombus right here, and I know that this is 30 and this is 30, I already have 60, which means I have 300 more to go. And I also know that these two angles are the same. So if I already have 60 and I need to get to 360, that would mean that this one is 150 degrees and this one is 150 degrees. Okay, so going on to the next slide, we have our student book, page 167. So I left it blank for you on page 8, so just so that you could see what it is and think about what kinds of angles we have here, and just imagine that we have our pattern blocks in front of us, even though we don't, okay? And I'm just going to go ahead and fill these in one more time for us so that we remember what they are. And you, if you could please open up to your student book, page 167, and do the same thing for me. So when I think back to my hexagon for a second, remember when I split it apart and I knew that it took 6 of those green triangles to make up my hexagon, and I know that each corner of the triangle was 60. Well, when I look at these corners of our hexagon, that's actually 2 of the triangle corners put together. So that would mean that each of the angles, so this would be 120, this would be 120, this would be 120, that would be 120, this would be 120, and this would be 120. Now this is a hexagon, so the angles in a hexagon are not going to add up to 360, okay? Now when I think about this again, I want you to just take a look at this one more time. And I know these aren't perfectly straight lines, and I apologize, but I know that 60 plus 60 is 120. So that kind of helps me see those 6 triangles put together. So those 2 corners together would be 120 degrees, right? Okay, now looking at the next one here, if I know that this is two triangles put together like we talked about earlier, then the measurement of this would be 60 and the measurement of this would be 60. I have 60. This is a four-sided figure. Okay. All right. I have 60. And 60 plus 60 is 120, right? Okay. Now, when I think about my triangles, the measurement of this angle is 120 and the measurement of this angle is 120. Now, if you look very carefully, this figure right here looks very much like this one right here, doesn't it? Very interesting, okay? All right, so that was very interesting. Okay, now also, looking at my number 3. That one is pretty easy because it's an equilateral triangle. That means all of the angles are the same and all of the sides are the same, which means that this one is 60, this one is 60 degrees, and this one is 60 degrees. Now, you should put your degrees symbols in there, and I apologize that I wasn't doing so. I was thinking that I didn't have enough room, but I'm going to squeeze them in there anyway because I want to do this the right way. Okay, so going down to number 4 here, thinking about how it took 3 triangles to make it, well, I already know that this is 60 degrees, and I already know that this is 60 degrees, okay? Now I know that this corner here and this corner here are basically 2 triangles put together, and I will show you that right now, okay? Which means that the this angle right here is 120 because 60 and 60 is 120. And this angle right here is 120 because 60 and 60 is 120. Okay, so there's that one. Now, we already know that this one is really easy. So this is a square. It has square corners. This is 90 degrees. This is 90 degrees. This is 90 degrees. And this is 90 degrees. Okay, perfect. So that one was pretty easy. And I went ahead and kind of looked at this one for you as well. And like I told you earlier, this angle right here is 120. This angle right here is much bigger. And if I know that quadrilaterals always equal 360, okay, and I know that this angle right here is 60, but this angle right here is much smaller than that, I'm going to go with this one is 30 degrees and this one is 30 degrees. And like we talked about a little while ago, that would mean that I already have 60 of my 360 degrees that a quadrilateral, the interior angle is equal, which would mean, again, that this angle right here is 150 and this angle right here is 150 because 150 plus 150 is 300. And then when you add those two 30s, then you have 60. So that is how you do this page. You may go ahead and fill this in, and please just take a picture of it and put it into Seesaw, okay? That's how you do this page. Moving on. Let's talk about angles a little bit more here. So we can make a 150-degree angle actually by putting together a square. So I know this is super small. It was supposed to be bigger and right here, but I don't know what happened. Anyway, but you can actually make a 150-degree angle by putting a square and a green triangle together because 90 plus 60 equals 150 degrees, okay? So an angle measures the amount that something turns or rotates. So when you think about a clock, for example, so if I were to draw a clock here, and if you think about a clock, I always like to start with 12, 3, 6, and 9, and then I go in and I fill in my other numbers because it just makes it easier to kind of see the clock that you're working with a little better. Okay, and here's like the center of the clock. All right, so when you think about a clock and an hour, the minute hand on the clock rotates all the way around 360 degrees. So if I were to grab my red for a second, we know that the minute hand is the longer hand, okay? When it goes all the way around the clock and it comes back up, that is 360 degrees that the minute hand went around the clock. And that's the same for the hour hand. It just takes the hour hand longer. Yes, it would take it much longer. So the clock face. So a full rotation around a clock is 360 degrees. So a full turn on a skateboard or even a snowboard, if you skateboard or snowboard, would also be 360 degrees. So when you fully turn completely all the way around, if you're facing north, let's say, and then you turn all the way around until you're facing north again, that's 360 degrees that you turned your body around, okay? So again, if you start at 12 o'clock and you rotate to 3 o'clock, so I'm going to get a different color here. So if you were to start at 12 o'clock and then you just went to 3 o'clock and that's where you stopped, think about that for a second. Well, now I'm looking at it, and if I think about fractions, okay, and if I've literally only gone this far around, that is 1/4, right? Okay, and if I look very carefully at this corner that I've made, that's a 90-degree angle. So if that's 90 degrees, my Apple Pencil is just giving me issues after issues here, boys and girls. I'm so sorry. So if that's 90 degrees, then if I were to go again, another 90 degrees, and it doesn't want to work anymore. Oh no. Okay. Okay, there we go. If I were to go another 90 degrees and then another 90 degrees, and I think about the facts that I know, I have made a complete square. So that would be 90, this would be 90, this would be 90, and this would be 90. Now I think about my facts for a second. 9 times 4 equals 36, which means 90 times 4 equals 360. So this is really cool how knowing your facts, knowing fractions is going to help you figure out measuring angles as well. Okay, so now we're taking a look at student book, page 168. So if you could go to the next page in your student book, page 168. All right, so this one is using pattern blocks to measure angles on a clock face. Now, I know that you don't have pattern blocks in front of you. I know that, and I've put a picture of them on the side here so you can see them. And we're just going to do the best we can with this. I'm going to have you do this page with me, and then we're not going to do the next page. We're going to skip that page, and you're going to do that one on your own, and then we're going to go to the next page. So anyway, I don't want to confuse you, but the directions are to use pattern blocks to measure each angle on the clock faces below. Then write the fraction of a whole turn around that it represents. Okay, so I want you to think about this for a second here. Now, when I was doing this page on my own, I noticed something. So the angle measure of this first one right here, we just talked about this. The angle measure of this one. Ooh, look at that. That, my friends, is 90 degrees. So go ahead and write 90 degrees. And we also talked about fraction of a whole turn. How far did we turn? We turned 1/4. Now, I want you to think about one more thing here, okay? I want you to think about how on a clock, we went from 12 to 1, 1 to 2, and 2 to 3. I know that that's 90 degrees. Now, if I were to split 90 degrees into thirds, okay, I know that 3 times 3 equals 9, which would mean that if this whole thing is 90 degrees, right, that would mean also that each one of these is 30 degrees. So this would be 30 degrees, this would be 30, and that would be 30. So keep that in mind as you start going around. Now, if you also think about right here, times 3, right? 3 times 3 is 9. So remember that. Okay. We're going to do the same thing here with this one. Now, I also want to pay close attention to this little thing right here. This is telling me that we're only going from here to here. It is not this area right here. Okay, it is not that area. So I'm going to color that. No, we're not talking about that. We're just talking about this area right here. Now, if I look very carefully, that looks very much like number 1, right? Again, that's another 90-degree angle. All right, so we have another 90-degree angle, and it's also only showing 1/4 of a whole turn. All right, okay. Now, moving on to number 3. When I look at number 3 very, very, very carefully, it's like I went from 12 and I literally went all the way around and back up again. Okay, so think about how far around I went, right? The angle measure. So when you see this black line here, this black line that's going around that dot, this black line that I'm highlighting, that means that's how far or how big my angle is, okay? So if I started at 12 and I literally went all the way around my clock and back up to 12 again, I went 1 I'm sorry, 360 degrees, okay? Now when it says fraction of a whole turn, it's not a fraction at all, it's 1 whole turn, okay? All right, now doing one more, number 4 here, looking at this one. So I want to pay close attention to this little thing right here. It's not all the way around. It looks like it's only halfway around. And when I look at number 1 and number 2, they can actually help me with number 4. Because from number 1, if I had gone another 90 degrees, then it would look just like number 4. So 90 plus 90, right? Interesting. That would mean that my angle measure for this one would be 180 degrees. And the fraction of a whole turn would be 1/2, which means I went 1/2 of the way around my clock. Okay, so that's how I do that one. Please go ahead and fill these in for me. Just write down the angle measure and the fraction of the turn. Snap a picture, post it into Seesaw, okay? And then I want to do this page with you, and then I'm going to have you do the next page on your own. So we're going to skip a page in our student book for just a moment. Okay, we're going to do page 170, and then we're going to go back, okay? So go to page 170 in your student book. Now, you don't have your pattern blocks, and I understand that, and I realize that. So I put these pictures on the side here to kind of help us out, okay? So we kind of did this a little bit already, but I put pictures that had angle degrees on them. So remember when we were talking about a little bit earlier, how if I were to split my hexagon apart, it basically is 6 of these triangles, right? And each of the triangle measures is 60. So if I were to put 2 of the corners together, remember that would be 120. So keep that in mind for a minute. Now, knowing that my trapezoid is basically half of my hexagon, so check this out for a second. My trapezoid is half of my hexagon, okay? So if I know that the measurement of this angle is 120, then this one's definitely going to be 120 as well, right? Okay. Now, if I also look very carefully, so I'm going to grab this for a second, blue. When I look at my rhombus over here, if I look really carefully, 2 triangles put together is a rhombus, which would make sense that this is 120 degrees and this is 60, right? Okay. Now, I already know a square. The only one that gets confusing is this one right here that we kind of talked about. And there goes my Apple Pencil again. Oh, my goodness. The only one that gets confusing is this brown one. But we talked about it earlier, so we should be okay with the brown one. Okay? So that one is the 150 and the 30. Okay? So it's kind of like the corner of this one is half of one of those corners. Okay? So that's kind of how I remember that one. Okay. So the directions are to use your pattern blocks, which you do not have, right, to measure the interior angles of each polygon below, and then label each angle with its measurement. Now, when I'm looking at this first one here, okay, I can see that the corner right here is just like the corner right there, okay, and that is actually correct. So the measurement of that, so it's kind of like we took the top of this right here and did that. That's basically what happened right there. And that's what happened right here. So if we did that, think very carefully. Well, this would be 120, and I know that because this is 120, right? So if that's 120, I'm already at 120. How many more do I need? Because remember that all the corners of a triangle add up to 180. If I'm already at 120, that means that I need 60 more, okay? Which means that the measurement of this angle is not 60, is it? No, 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 no. What would be half of 60? It would be 30, right? So this one would be 30, and this one would be 30, because 120 degrees plus 30 degrees plus 30 degrees, that equals 180. And all triangles add up to 180, boys and girls, okay? All right, now, looking at the next one right here, I've got some pretty easy corners here. I've got this easy corner, and I've got this easy corner, okay? I automatically know that this is a 90-degree angle and this is a 90-degree angle. Now, I already have 180, and I know that a quadrilateral adds up to 360, okay? Now, looking at this very carefully, this corner right here, this angle right here is just like this angle right here, okay? So that, my friends, is 120 degrees. All right, so thinking about this for a minute, I have 120 plus 90 plus 90, or I could think about it this way, 120 plus 180. That, my friends, is 300. I only need 60 more, which means that the measurement of this angle right here is 60. So 90 plus 90 plus 120 plus 60, that equals 360 degrees, because all quadrilaterals add up to 360, okay? All right, now let's take a look at this next one here. Now, when I look at this next one, there are a couple parts of it that remind me of a shape that we were talking about that was tricky for us, and that was this one right here, okay? So this corner right here, this angle, is exactly like this angle right here. So this is 150 degrees, okay? Now, this is not a quadrilateral, okay? This is more than a quadrilateral because it has 1, 2, 3, 4, 5 sides. Think about what a 5-sided shape is called. That is called a pentagon. Penta means 5 and gon means angle, so that just basically means a shape that has 5 angles, okay? All right, I'm going to erase this stuff so it doesn't get confusing for you. Okay, so if this is 150 degrees, now this corner right here is just like this corner. This is 30 degrees. Ooh, this one right here is pretty easy. That is 90 degrees. Now, I have 2 more corners. Now, if I look really closely at this one, boys and girls, it's identical to that one. This one is 150. Now, when I look at this last corner, it is not quite as wide as the 150 degree angles, but it does look like a corner of a shape that I already have over here, okay? Now, it's not quite 150, but when I look carefully at the other shapes, it's 120, okay? So that's that one. All right, so 150, 150, 30, 90, and 120. Now we have one more shape to look at, and that is this triangle. And boys and girls, in Mrs. Sanders' math class, we have talked about this kind of triangle before. So this is not the typical equilateral triangle that we have right here. This one has 3 different sides to it, right? Okay, so you have 3 different types of triangles. You have an equilateral triangle, you have an isosceles triangle, and you have a scalene triangle. Now, an equilateral triangle means basically that all 3 sides are equal, all 3 angles are equal, okay? When you have an isosceles triangle, an isosceles would mean that 2 of the sides are the same length and then 1 is different. So these 2 would be the same and this one would be different. And then you have what's called a scalene, which means that all of the sides are different lengths, okay? So when I look at this one right here, this is the shortest side, this is the next shortest side, and this is the next shortest side. This is a scalene triangle. But it actually gets a little bit more specific than that because one of the angles in this triangle is special, okay? One of the angles, this guy right here, if I look really carefully at it, this is a 90-degree angle. So this is considered a right scalene triangle because it does have a 90-degree angle in it, okay? So if this is 90, and I know that all of the sides of a triangle, or all the angles, I should say, add up to 180, I've already got 90, which means I only have 90 more to go. Now, when I look over at all my shapes over here, I need to come up with 3 angles that measure 90, right? That add up to 90, because that's all I have left. And the only 2 that I see would be 60 and 30, okay? So that means that the measurement of this angle right here is 60, and the measurement of this angle right here is 30. Okay, So there's a little side note on triangles there. You may go ahead and fill this in. I know that you don't have the pattern blocks to look at, and I apologize, but I did want to just teach this to you because it's really important information and stuff like that. So you can fill this in, take a picture, but what you are going to do on your own now, okay? So this is the last step of the lesson that you're going to do on your own, and that is this page right here, okay? So you're going to go back to page 169 in your student book. I want you to complete this one on your own. If you need to go back and look at page 168 to help you, please do so. I just want you to remember when you're looking at this part right here, this is telling you how big the angle is. These are big angles, boys and girls. These two right here, these are both obtuse. Ooh, this is also obtuse, but this one right here is so little, so it's not obtuse. All right. Okay, boys and girls, so you're doing page 169 on your own. You're going to do awesome. Keep up the good work, and I will talk to you tomorrow.